Okay, in this video, I would like to demonstrate a simple ventilation analysis, natural ventilation, using external wind in a building with tensorHVAC-Pro, which is a dedicated flow and thermal simulation software for HVAC engineers that you don't have to have expertise in CFD. Okay, without further ado, let's jump into the tutorials. So of course, let's first create the new project. Let's call it external flow. Then let's select the project directory that you want to save your project folder. Okay, this is the first step. You can import your geometry in a XTL format, which you can export directly from Revit or maybe SketchUp if you are architect or maybe civil engineers. And if you are mechanical engineer, of course, you can also export your model from Autodesk Inventor or maybe SolidWorks or Fusion. And yeah, basically any 3D modeler software available in the market can export STLs. So yeah, you don't have to worry about that. Okay, let's import our geometry. Maybe I will also share you these STLs in the link in the description below. Okay, this is very simple house. I will hide the roof so you can see what's inside this building. So yeah, very simple building. And we have our windows opens, so you can see here. And as you can see, the model here is in the positive domain, not a negative domain, so you don't have to convert by cut like just like traditional CFD software. Okay, here we have selections for the boundary conditions. Inlet and outlet basically used for like air conditioning unit like the diffuser, but in this case we don't need the inlet and outlet. You can check another tutorials to use these boundary conditions. And objects basically used for like a human body or maybe some chairs or maybe tables with small details. But here we will just use the wall, which is like if you have flat surface like the ground or maybe roof, or these side walls will be wall. Okay, so let's set everything to wall. And yeah, from this scale you can also make sure that your model is exported and imported correctly. Otherwise you can use these transformation features to scale or maybe translate or rotate if necessary. Okay, for the mesh, you can select the default, which is medium. You can also actually show the wireframe to check your resolution, fine or coarse, or you can even use manual input. But it doesn't really matter actually. If you want to make it finer, the resolution of the result will be much better, but it will take longer to run. So yeah, that's the trade-off of the CFD simulation. And for the object, we don't have any object here, so we don't have to worry about this setup. Let's click the update mesh. It will take a couple of minutes because we have external flow, which needs a lot of nodes and elements for the mesh. Here we go. Just takes a couple of seconds. You don't have to check the mesh actually, but it is always a good practice to always make sure that our mesh are generated properly. Here we go. We can see the walls and the external wind. Oh, I think I forgot something. We have to. Oh yeah. I did it correctly. So you have to check the wind, so it will simulate the external wind. Okay, let's go to the next step, which is the boundaries. We don't have to worry about this inlets condition. We just have to input this external wind velocity, which will be in the, let's say, negative z direction, and maybe in a little bit in the x direction. Or you can, define it based on your own data. So it's just like arbitrary value. If you like, you can also change your wind temperature in Celsius or in Kelvin or Fahrenheit, and the velocity you can also change it to your preferred units. For the wall, let's say for the roof, which gets some thermal radiation, you can check here for some reference if necessary. Yeah, so you can check the value of the temperature gradient based on the heat flux and K value. But it will be different, if you simulate it for the different weather condition or the season. I mean, like if you are simulating winter and also summer condition, that will be different inputs. Or maybe it is during morning, day, or night. Of course, they also will be different. But yeah, let's just put some random inputs so we have some, so we can get some interesting temperature gradient results. Okay, don't forget to update the boundary conditions, and let's go to the general setup, which will be used for comfort analysis. Again, maybe we will make a special video about how to define this comfort, but mostly it will be related to the standards like ASHRAE or maybe ISO. So for now we just ignore this one, and yeah, this is the last step, which is solver setup. Let's just change the end time. So the end time is basically the number of iterations. So the larger the number will make your simulation more converts. It means it will not change with the iteration anymore, but it will take longer to run. And the write interval is basically just how many iterations you will save your data. So let's say if you have 2000 iterations or end time with 100 interval, you will get like 2000 by one divided by 100, which is like 20 data stored in your ParaView or your database. And this is the number of cores. So the number of cores is the processor that you will use to run this simulation. So essentially, the larger the number of core will be faster to simulate, but of course it will be limited by your hardware. So yeah, you have to understand how much your hardware, your number of cores in your device. But the larger number of cores will be slowing down the other process. Maybe if you are working in this simulation and rendering some video or maybe a 3D model, maybe that will slow down that process. But yeah, this is up to you. Okay, don't forget to update the setting if you make any change, and let's start the running. And this is just the logs, so you don't have to worry much about this. It just tells you the residual values, like the error generated from the simulation, and maybe if anything goes wrong, you can see in these logs, and you can check our discussion forum in order to get some troubleshoots. And here we can see the residuals of our iteration. So if we have lower residual, it means like it's more zero after comma. Like if you have like 1 to the power of -4, it's like 0.0004, something like that. So the lower is better. And if the line doesn't change with the iteration anymore, that also indicates that your simulation starts to converge. You can check the other parameters like the velocity here, the U, H is enthalpy for the temperature, K and omega are the turbulent parameters. So let's skip this part. Maybe it takes a little around like 10 to 15 minutes. So yeah. Okay, here we go. After a couple of minutes, we finally finished the iteration. So it already 2000, and it will generate some values every 100 iterations. So let's check the result on ParaView. Here we go. Let's see the result. You can only see the box, but let's first change it to the last iteration, which is 2000. Let us make some slice to see the what's going on inside this box. So yeah, let's first change the color and make it featured edge so we can see the inside. And let's create the slice in Y normal. And yeah, let's make it just a little bit above the window so we can see the interaction of the flow around the window. Let's hide the plane and see what's happening for the velocity. Here we go. Very beautiful plot to see what is going on inside this room or this house or building. Then we can also see the temperature. We have some raised temperature from the wall because of that radiation, I mean the temperature gradient. And we have a hot temperature at some location in the house. We can also see the air age, which is the air, the longer the air trapped in that building will be more red color. And we can also check the DR, PMV, and PPD, which again we will discuss this in the other video. Yeah, but it is related to the ASHRAE standard or maybe ISO standards. And maybe let's create vector lines here to make our simulation more interesting. So let's create a ellipse. For the scale, let's not scale it. Oops, it's too large. Let's make it smaller. Here we go. Let's make the color a solid color, or yeah, we can make it black actually. Let me check. Here we go. Let's make it black, and let's make maybe yeah, that's fine. Maybe we can change the opacity of this plot to see the vector better. And here we go. We can see this picture from above, so you can see what's happening in this building, or you can tweak your parameters if you like to make to lower the scale, let's say, or you can add the number of samples point to make it denser. Here we go. Maybe that's all for this video. Okay, if you have any comment or a question related to this video, or maybe if you have any request for to discuss related to HVAC, please comment in the comment section below. And tensorHVAC-Pro also comes with free version, so you can also try its free version. Again, I will give you the link in the description below. And thank you for watching, and see you in the next video.